Newtonian drop, because we assume the flow is what we call Newtonian fluids. And if you have you ever studied fluid mechanics? Somebody here? No mechanical engineer in the room? Sorry? It's a viscous material, and it has a certain properties. A viscous fluid under certain conditions is called Newtonian fluid. And this is how the drop, if you ever wonder how a drop in an inkjet looks, this is how it looks after formation, during the formation, during the necking process, when the neck is broken, and then you have the drop. By the way, you have this white spot here. It's not real. It's just because it's a ball. When you look at it, at this point, the light from the camera is being reflected, because when you have a ball in front of you, only here the light is reflected back to you, while from here the light is diverted. So this point looks white, and the rest looks black, but it's not real. This is not the real color. This is just because when you look at the ball, and when you image the ball and the light is coming from here, you see only the center of the ball reflects back to you. But it's good because we know where is the center of the ball. Another technique which is very widely used is called aerosol jet printing. Instead of using a force to pull up and down the liquid, you're basically generating an aerosol, which is this particle floating in air, and you are having some very cleverly designed nozzle, so you're generating a beam of the dots flowing toward the surface. The big advantage of this technique is that you can get very high printing speed. The disadvantage, I don't remember the last numbers, but I think it's difficult to go below 100 microns. So it's not high resolution, but very high speed, and can be very useful for packaging. So this is and then other techniques is called direct write extrusion. You make, and this was done in PARC. PARC is the research lab of Xerox. And you're generating a nozzle, and you're depositing your material by simply pushing. In this case, the ink is not viscous fluid. The ink is like a melted plastic or melted polymer that you actually like depositing it on your substrate. And you can make this structure or even direct deposition of the polymer directly. And people made these kind of structures using direct deposition of the polymers. Not so much useful for electronics, but very useful to make components. And this will be like these pictures will take us to the next topic, which is 3D printing. Before we go to the next topic, there are some other printing called transfer printing. It's a cheap micro transfer printing that you can actually transfer one material from another. Like this is like a Band-Aid, when you take a plaster and scratch it and remove the cover. So this is called transfer printing, but again, we'll skip this one. The holy grail is to go from inkjet, which is good for prototyping, and gravure, which is relatively high speed, to go to production scale mixed processes. Imagine that you have, you print here metal, you do inkjet of semiconductor here, you print another metal. So ideally, and this is a real machine, by the way, but for prototyping, you can, I don't know exactly what they have in this machine, but you can think of a machine that can print mixed processes in every stage, and then you put the plastic in one side, and after a few minutes, you have the full product coming on the other side. And what they do, they, for example, printed test structures. This is, you have to, do you see this? This is a test, this is a design of the test structure. This is the test structure printed on the multi-layer devices, on the plastic. So this is the first part of the lecture, when I gave you like a 1 hour overview of all possible 2D two-dimensional printers today. And there is a lot of research today in inkjet printing, in gravure printing, and integrating processors, and also laser printing. I will not go through all the details of all of them. I just gave you 1 hour overview, so you can. This is like a break between the previous lectures and the next one. Let's take 10-minute break and then continue with 3D printing. 2D printing and to 3D printing. I was asked one question, if I can make high-resolution 2D printing. The answer, yes. There are possibilities to do 2D, two-dimensional printing with very high resolution, and there are even products in the market that you can print with very, very small drop, so very, very small nozzle, and you can print really even sub-micron patterns. The problem, it's very slow. And it's very slow, so you cannot use it to compete with conventional lithography. So if you want to do sub-micron devices, don't use printing, use lithography. If you want to do above 50 microns, you can either do lithography or printing, depends on what you want. And the issue of printing is become more and more relevant. More companies are producing high-quality equipment because it's very attractive to use printing. It's very low cost in manufacturing, very versatile, low capital cost. And the next issue is 3D printing. And again, this is a table which you don't need to remember, but again, this table is taken from this paper. And look at the date here. It's 1990, just before the year 2000. So it's this is a review paper, and it has all the methods of printing. I'm not going to dwell on this slide because we are going to. So first, what is 3D printing? The general idea of 3D printing, and later I'm going to talk about 3D for electronics. But let's talk a little bit about general 3D printing. Not only for electronics, not only for nano, but general. So let's say you have a model. You start with a 3D model. You can model in a 3D software, or scan an object with a 3D scanner, or download from somebody else. This is the adventure of getting files. Okay, let me repeat for the people who just entered. I'm talking about 3D printing. We changed topics from 2D to 3D. And there's even, by the way, there are even 4D printers today. 4D printers is just 3D printers that after you print, they start to change. But let's stay in this lecture today in 3D. You can, let's say you have a 3D model. Either you model it with a 3D software, or there's an option that you take an existing object and use a laser scanner to get an image, or a camera to get the structure. And then you have the file which describes the shape of the feature. And then, for example, one option, you take this let's say you want to print this structure. So, okay, I can print this structure if I make it out of layer after layer. And then what you do, you print layer after layer after layer. So 3D printing software slices the model in many, many 3D cross sections. So if you have the model here, you slice it, and then you print it. Now this method, I'm going to use FDM. What I'm showing you here is printing using FDM, and I will explain it to you exactly what is FDM, but you have a nozzle dispensing the material that you build it layer by layer by layer by layer until you end up